Example 9. The graph of a one-to-one function f is given. Draw the graph of the inverse function f inverse. All right, so we have a couple of graphs here. So let's take a look at the graph in part A. So here it is. What the graph consists of, it's the blue graph. The red dotted line, that is the line y equals x, because remember that's important for drawing inverses. So make sure you understand that y equals x is not part of the graph. It's just there for reference to help you draw the inverse function. F is the blue graph that consists of these three line segments, okay? So just like when we would draw symmetry, or even transformations, there are 4 points that are called out or emphasized on the curve. We're going to move those guys and then the whole graph will move, okay? So first thing I want to mention to you, okay, we're drawing an inverse function. This has nothing to do with symmetry. This has nothing to do with transformations. This is a whole new deal, okay, drawing an inverse. Okay, you've got to keep your rules straight. Okay, on the final exam, you may be asked to draw symmetry or recognize symmetry or do the same thing for transformations or inverses. You've got to keep your rules straight. Okay, if you're asked to draw an inverse function, the key to inverse functions is switching x and y. So this is how we're going to do this. Okay, I'm going to make a list of old points and new points. Okay, so the points that are called out on the curve are -2, -2, and then 0, -1, and 1, 0, and 2, 1/2. Okay, it's extremely easy to do this. To get your new points, all you have to do is switch the x and the y coordinates. Okay, so if we start with the point -2, -2, they're the same. X and y are the same. So if you flip-flop x and y, you're going to get the same point back. Okay, so -2, -2 is going to be on the graph of f, and it's going to be on the graph of f inverse. Okay, moving on to the next point, 0, -1. Okay, we're going to switch x and y. The new point's going to be -1, 0, which is right here. Okay, and then on the curve of f, we have 1, 0. We're going to switch x and y. That point's going to go to 0, 1, which is right here. And then lastly, the point at 2, 1/2 is going to switch and go to 1/2, 2. Okay, that's it. Now be careful when you're locating this last point. Make sure you recognize the scale on both the x-axis and the y-axis. Notice there's a tick mark every 1/2 unit. Okay, like if I'm looking at the x-axis, this is 1/2, 1, 1.5, 2, 2.5, 3. Okay, be very cognizant of the scales being used here. So the last point, 1/2, here's where x equals 1/2, if you can see where my cursor is, and then the y value will be 2. Okay, that will be right here. We have to draw in the graph. Okay, you're going to connect the 4 green dots in the same manner that the original graph is connected. We're just going to go from left to right and connect each pair of points with a line segment. Okay, so I'm going to start on the leftmost point here. I'm going to connect it with a line to this point. Okay, now I'm going to draw a line segment from this point to this point. And then lastly, I will connect these 2 points with a line segment. And then what results is the graph of f inverse. Okay, notice what we have drawn, the green graph and the blue graph. They are mirror images of each other about this red dotted line y equals x. If we were to fold the sheet of paper along the red dotted line, the green graph would lie on top of the blue graph. Okay, so you can kind of judge, visualize if what you have drawn is correct. Okay, so again, let me label this and let's move on to the next graph. Okay. All right, here's the graph in part B. We're doing the same kind of thing. The red dotted line y equals x is just there for reference because whatever you draw in as the inverse function has to be a mirror image of the original function. Okay, so the blue graph is f. It's a little bit different here because we don't have any points that are called out or emphasized for us. So it's going to be a little trickier. Okay, what we can do is we can try to recognize some points on the graph ourselves. So like if I look at this point right here, okay, this point is on the blue curve. This is 1, 1. Okay, and if I look at this point right here, -1, -1 is also on the curve of F. Okay, so I'm going to go ahead and start making a list here. I can read some of these points off, like 1, 1 is on the graph of F, and -1, -1 is as well. Okay, and even the origin, the blue curve goes through the origin. Okay, so these are all points on the graph of F. Okay, what's weird, or not necessarily weird, but not helpful, I should say, is if you switch the X and Y coordinates here for each of these ordered pairs, you get the same point back. Okay, because the X and the Y coordinate match for each of these ordered pairs. So these 3 points that I just called out here, they are points on both the original curve F, and they're also points on the inverse. Okay, so this is not going to be totally helpful. Okay, so what we're going to do here, I mean, if you scan this blue curve, nothing else on the blue curve falls nicely on a grid point, so it's going to be hard to read off any additional ordered pairs. Okay, so this is what we're going to do. Okay, I'm going to break this curve up into little segments. Okay, I'm going to go ahead and highlight this. Okay, so just stick with me. Okay, let's look in this little yellow square for a second. Okay, let's try to draw the inverse piece just in this little yellow square. Okay, so ignore the rest of the graph. Okay, so you see where the blue curve is. Okay, so the blue curve is right here. Imagine folding the sheet of paper along the red dotted line. Where is this curve going to go? Okay, we know the inverse is still going to go through 0, 0, and it's still going to go through 1, 1. But if you were to fold the sheet of paper along the red dotted line, then the blue curve is going to go, the piece in the box is going to go something like this. Okay, it almost forms like a leaf, looks like a leaf. Okay, again, we're focusing on what's in the yellow box. Okay, if you fold your sheet of paper along the red dotted line, then let me erase the yellow box. Okay, you can see that the blue piece would lie directly on top of the green piece. Okay, so we're just going to break the curve up into segments. Okay, and keep trying to do this. Okay, so now I'm going to move down here. Okay, same kind of thing. I'm only focusing on this piece. Okay, so for this piece, okay, we know the inverse needs to go through 0, 0. It needs to go through -1, -1. You need to imagine folding the sheet of paper along the red dotted line. Where is this blue curve going to go? Okay, well, it has to be a mirror image about this red dotted line. Okay, so it's going to look something like this. Okay, so now if I erase the yellow box, okay, what we have, if you were to fold your sheet of paper along the red dotted line, the blue graph should lie on top of the green graph. Okay, so we need to do it for a couple of more segments. Let me go up here. We haven't done this piece yet. Okay, so again, we need to draw the inverse in such a way so that if we did fold the sheet of paper along the red dotted line, then the blue curve would, fall directly on top of what we draw. Okay, so you kind of have to visualize this. It's going to look, well, hold on, let me try that again. It's going to look something like this. Okay, so again, it's just taking some visualization here. Okay, you need it so that if you fold the sheet of paper along the red dotted line, okay, the blue curve will lie directly on top of the green curve. Okay, I'm trying to erase it, so there we go. Okay, I don't know if I'm gonna be able to erase this. I might have to just keep it there. There we go. Okay, so in that little square, okay, you can see it better now that the yellow's gone. If we do fold the sheet of paper along the red dotted curve, that blue piece should lie directly on top of the green piece. Okay, all right, let's look in the bottom left hand corner. Okay, so we're going to look down here. Okay, we're going to have to do the same kind of thing, just visualize it. Okay, if you were only looking in this box and you fold the sheet of paper along the red dotted line, where is this blue curve going to go? Okay, well, it's going to look something like this. Okay, so that if you do fold your sheet of paper along the red dotted line, the blue curve will lie directly on top of the green curve. Okay, so this one was definitely harder because you didn't have, first of all, it wasn't, just line segments. It had some curve to the graph. Okay, and there were the points that you could read off the graph weren't very helpful for forming the inverse. Okay, so you can look at the finished product. Overall, it looks kind of like a DNA strand. And also, if you do fold your piece of paper along the red dotted line, as a whole, the blue graph will lie directly on top of the green graph. Okay, so this is how you need to draw an inverse function. Okay, so again, like I said, if you end up, on the next exam or even the final exam, if you have to draw an inverse function, if there are points you can read off the graph, write them down and then switch the x and y coordinates, and those are going to be your new points. Those are going to be points on the inverse. Okay, worst case scenario, you can't read many points off the graph. You're just going to have to use the line y equals x as a reference, because the original function and the inverse function, if you graph them out on the same grid, they are mirror images about the line y equals x.